Imagine looking up at the night sky. You see those familiar points of light, the planets wandering among the stars. Now imagine we could reach out, pick one, and transform it. Not over millions of years, but in a single decade. Could we really take a cold, dead world and turn it into a new Earth? A place with blue skies, flowing rivers, and breathable air. A second home for humanity, built from scratch in just 10 years. It sounds like something from the pages of science fiction, an impossible dream born from our oldest desire to explore. But is it truly impossible? Or are we standing on the cusp of an age where we can shape entire worlds? This question isn't just about technology. It's about our future as a species. The idea is staggering, isn't it? To fundamentally alter the nature of another celestial body. So what do we actually mean when we say terraforming? The word itself gives us a clue. Terra is Latin for earth, and forming means to shape. So terraforming literally means to make Earth-like. It's the process of deliberately changing a planet's environment to make it habitable for humans. This isn't about building a few sealed domes or underground habitats where we need life support to survive. It's about transforming the entire planet. We're talking about creating a breathable atmosphere, raising the temperature to comfortable levels, and establishing a stable water cycle with oceans, rivers, and rain. If we were to embark on this grand project, our first question must be, where? Which planet would we choose? Venus is a hellscape, with surface temperatures hot enough to melt lead and a crushing atmosphere of carbon dioxide. The gas giants have no solid surface to stand on. The moons of Jupiter and Saturn, like Europa and Titan, are fascinating worlds, but they are incredibly cold and far from the sun. When we weigh all the options, one planet stands out as our most promising candidate, Mars. The red planet has long captured our imagination, and for good reason. It is our celestial neighbor. A day on Mars, called a sol, is only about 40 minutes longer than an Earth day, which would make for a familiar cycle of day and night. The planet has a tilt similar to Earth's, giving it seasons, albeit colder and longer ones. We have found compelling evidence that Mars once had a thicker atmosphere and vast amounts of liquid water. So we've chosen Mars. How do we transform it in just 10 years? The first and most crucial step is to thicken its atmosphere and warm the planet. We need to trigger a runaway greenhouse effect. One idea is to build giant orbital mirrors, huge lightweight structures that would reflect sunlight and focus it onto the polar ice caps. Another, more direct approach would be to build factories on the surface of Mars. These automated facilities, often called greenhouse gas factories, would be designed to mine the Martian soil and bake it, releasing the trapped gases. This would begin to thicken the atmosphere. We would start to see rivers flowing in the ancient riverbeds for the first time in billions of years. So to achieve such a monumental task in just a decade, we'd honestly need technology that's way beyond what we currently have. The initial workforce, interestingly enough, wouldn't be human at all. It would actually be an army of autonomous robots. And get this, they'd be designed to be self-replicating, able to use Martian resources to build even more of themselves. Just imagine releasing swarms of nanobots into the atmosphere. They could also help prepare the soil for biology. The microbes and algae we'd introduce would be products of advanced synthetic biology, making them perfectly suited for the early Martian environment. This biological toolkit would be the living, self-sustaining part of our terraforming machine. Undertaking a project of this magnitude is fraught with danger and ethical questions. The first and most obvious risk is that of the unknown. Could there be native life? It might not be little green men. This raises a profound ethical question. This is a decision with irreversible consequences. Then there are the technical risks. Our models of planetary climate are still imperfect. We could overshoot our target temperature and accidentally turn Mars into another Venus. The cost of such a project would be astronomical. This could lead to immense political conflict on Earth. The first generations of Martians would be living in a grand but dangerous experiment. Our 10-year plan for terraforming is breathtakingly ambitious when we compare it to the pace of natural planetary change. It took Earth billions of years to become the planet we know today. The greatest change to our planet's atmosphere, the Great Oxidation Event, illustrates this perfectly. We would be compressing billions of years of natural change into a single decade. Successfully terraforming a planet like Mars would fundamentally change humanity. It would be the single greatest achievement in our history. marking our transition from a species confined to one planet to a truly multi-planetary one. It would be a profound shift in our perspective. Having a second home would change our definition of who we are. As we stand on the precipice of such capabilities, we face a fundamental choice about our future in the cosmos. Do we become a species that tames worlds? Or do we become a species that wanders, that explores and studies the universe as it is, preserving its natural state? This is the core dilemma, deciding which worlds are for settling and which are for wandering. So as we look out at the vast, dark emptiness between the stars, we must ask ourselves, what comes next? Do we build a new garden, or do we simply continue to explore the wilderness?